Now I'm going to open up a Google Doc like so. Uh, Blank, right? And I'm going to name it Do Now. And this will be and the reason we name it is because we can find it. If you put untitled, if you leave it as untitled, you'll have a bunch of untitled documents, and that'll be a headache because you got to click through each one. But if you name it, especially the way I do it by date, you can find it easily. So as of today is the 14th of July, and I'm going to put my header, which is Mike Tyler II, and today again is the 14th of July 2020. Period is 1, and this is physics. And now I need the problem, which is here. And I'm just going to take that like Mario did. And that allows me to go here. So looking good. The title of this document is called Do Now. Right. I wonder if Eli's just waking up late. All right, so we're going to space out a little bit because we're going to do each of these in steps. I think the only problem that you got to do on your own is, where is it? Speed, probably number 1. So I'm going to start with the most difficult part, which is number 2, because you got to find the speed. And then I'm going to do number 3 with you guys as well. So let's go through it slowly. We need the equation for kinetic energy. So in order to get that, we can just open up a tab. I was trying to clean my glasses real quick. Open tab. And if we look here, kinetic energy is, who's in here?
Can you send me that code?
For Miss Lane's class?
Yeah.
1 second, Miss Hens. I gotta go to my calendar.
Okay. Mr. Tyler, today my birthday.
Happy birthday. How old are you now?
17.
All right, you're getting up there. Come on, calendar. What are you doing? Oh, because I'm in the CPS calendar. I gotta go to my Camelot calendar. There we are. And you're trying to get into, what is this? That's geometry. Spanish. Here it is. Environmental science is where you're supposed to be. Let me go and grab that and put this in here for you. So are you seeing the chat?
I see the chat. I see it.
Okay, that should be the link to our class.
Thank you.
All right. Okay, so where was he at, Mario? This is the wrong calendar. Here we go. So now I was about to do, I said, was it problem 2? Problem 2, you need to know what kinetic energy is. So that is, what is the equation? If you ever wanted to know it, you can find out more of kinetic energy, right? So if I put that in, it has a few different variations in the symbols, but trying to find something that tells you it's right here if you can see it. And I'm doing the best I can for you because we don't have, any of the books or any of the classroom space. So this shows the equation for kinetic energy. And you can find it in other places. Then there's the equation for potential energy down here. But we're going to use this one, which is Ke for kinetic energy is equal to 1/2 times the mass times the velocity squared. Okay, so with that known, we're going to say use the equation for kinetic energy, which is, say Ke, kinetic energy. I'm not going to use Ke yet because I want you to know exactly what it is equivalent to 1 divided by 2 1/2 multiplied by the mass multiplied by the velocity, and that's going to be squared raised to the power of 2. So now we need to start setting up our known and unknown values. And when we do that, we can actually begin solving for the speed. Now, speed in this calculation is known also as the velocity, and speed is usually a scalar. So when it's a scalar, it has no direction, and I didn't tell you direction. But it's also known as a velocity because when you give it a direction, it now is a vector, which makes it velocity. So known values, right? You specify what those are, and unknown values. Mario, can you see what's on my screen, or do I gotta maximize some more? Because it looks small on my monitor.
Just a little bit.
Okay, that's what I was wondering. How about now?
Yeah, I mean that's good.
Okay. Tell me something, because you're gonna need to take notes on this to get it done. Don't sit there and be quiet. All right, so we got our unknown and known. Now, what are they? So known, what did they give us? They said, what is the speed? So I already told you that's going to be velocity, which is going to be a trick to it because you got to do some algebra on the square root, or on the power of 2, which is known as the square root reverse. So they give us a mass, which is 0.22 kilograms. Now, mass is always some form of kilogram or grams, but it's usually kilograms because we're dealing with high levels of energy. And we said that's 0.22 kilograms. Okay. Next is what? Well, let's come down one. What else did they give us in here? Now, they said, whose kinetic energy in the problem here? Whose kinetic energy? They're telling you another thing. So we're going to say KE for kinetic energy is equivalent to 72 joules. Okay. And next, what are we looking for? Well, they asked you, what is the speed? And that's velocity. Also known as speed, is equivalent to some number we're going to calculate in meters per second. So we got the initial setup, but now we have to do some serious algebra on this problem. So we're going to take this equation, and the shorthand version of the equation is KE is equal to, you can say 1/2, or you can say 0.5, because 1 divided by 2 is the same as 0.5, or 50%, multiplied by M, multiplied by V, and that's raised to the power of 2. So I'm going to take this and now solve for the speed or the velocity using algebra, right? I'll put this in here, and this is the equation we're going to start with because that's what we said we were working with in terms of kinetic energy. All these questions are going to be dealing with the kinetic energy equation. You're just going to have to manipulate it or solve for it outright. So first thing I want to do is remove everything around the velocity squared. The way that I can do that is understanding that the 0.5, the mass, they're both multiplied into that velocity squared. So what you do to one side, you got to do to the other. And take this and make some changes using our algebra skills. So the reverse of multiplication is division. So we'll come down and make a division bar here. I'll space this over because it's a lot to put in the bottom. And I'm going to make, clean this up some, a division bar here. And what I want to do is I want to take the mass and the 0.5 and use that as a way to divide out what I don't need. So I'm going to put this down here. All right. And I'm also going to put this over here. So now let's show what changed in the problem set. So these are the changes that I made to the equation to get velocity almost by itself. Because once we do that, we will still have velocity squared. So these are the changes. That's not the right way to do that. Okay, so now I can cross out this one because this 0.5 in the mass will cross out with this 0.5 in the mass. So I can cross this out. And I can also cross out all of this because it cancels with the denominator. So that crosses out. And now I have a new equation. Let me turn these things off. Okay, turn that off. And then if I come down, it becomes, let's write it correctly. It's going to be velocity raised to the power of 2 is equivalent to what we have here, which is, we said KE, and that's going to be divided by, I'll put the KE in the middle of that, and then divided by that 0.5 here. I just rewrote it so you can see it, and it looks cleaner. And that goes here. So now we have the new equation of KE is equivalent to, I'm sorry, velocity squared is equal to the kinetic energy divided by 0.5 times the mass. All right, but we're not done, right? We still got to figure out how to get our velocity all by itself, because that's raised to the power of 2, and that's not the same thing as velocity by itself. So we got to use a technique called square root, which will reverse, a mathematical technique called square root, which will reverse everything here. So let me take this and plug it in one more time, because we still got to do one more thing to it before we put our values inside of it. Okay, keep that together. And what does that become? Well, if we use the square root, so that's usually, the square root is like, you've dealt with square roots before, right, Mario? It's got it's like an upside down V or elongated V. So square root symbol looks like this. We're going to put this on both sides. It's going to be kind of tough to do because I got to find out if there's a symbol. Let's see if it's in special characters or equation. No, that's not what I wanted you to do. So hold on. Insert. Because I've seen a student do this. So I'm trying to see if I can do it. Special characters. All right, here we go. And what I want is square root. I'm looking for it. There's another way to write it, but I'm trying to make it easy for you when you do it too. So symbol, just symbols, guys. All right, so what about square root? Bingo, I got lucky. Okay, I did this last night. I was gonna see if it failed me today. All right, so I'm gonna move this over, and I'm going to take that out and put this over here. Now that means the square root is going to cover everything around the velocity squared. If you're doing this by handwriting, it looks a little bit better because you can just draw the square root across the top of it. And then what you do to one side, you got to do to the other. So this entire thing will be square rooted as well. So that's going to be, if I move it over, and I think I got to write this a little bit better. So let me do this. I'm going to say this is the square root of this. And then I'm going to bring this upstairs so I can square root the entire thing. Right, something wrong there. And I'm going to take that out and put this here. And all of this will be in brackets because all of it needs to be square rooted. I should have just put parentheses, which I think I will. Okay, now remember we got to square root this, because what you do to one side, you do to the other, and this allows you to cancel out the power of 2. So that means the square root, which is this symbol here, is going to occur on both of these elements. So let me make that a little bigger. Say that's about 14. So you'll see the square root, and usually there's a bar that goes across, kind of like this. This bar will go across the top of it. But I've just put that there so you can see what the square root is about. I made this 14. That's the change to it. So this is not a change. Let me change that back. But these are the changes, the square roots. Okay, so you can see that. Now, what does that become? Well, like I said, this part right here, this square root would cancel with this power of 2, leaving the velocity only. So we end up with velocity, or speed, is equivalent to the square root of kinetic energy divided by 0.5 times mass. That's the next step. So now we're at the fun part of the problem, plugging our numbers in. And we got one more problem to do after this, and it's not as bad. This problem, number 1, you're going to have to do on your own because it uses some algebra and you solve math. So let's hurry up and finish this off. Well, the numbers inside of the problem now, that becomes what? Well, we just got to go back to our known and unknowns. That's velocity, or speed. So what we're looking for is equal to, again, the square root, which is this sucker, and parentheses, what do we got? Well, we got to look upstairs in our known and unknown section. So we started with at least 72 joules. That was our kinetic energy. So 72 joules, right? That's divided by our 0.5, because that's also in there, multiplied by what do we say our mass was? Let's go back upstairs. That's 0.22 kilograms. Right? So now when we put this all together, joules divided by kilograms, you end up with velocity. And inside of joules, you have, I think, a kilogram and a meter squared per second squared. So that's a fun note. So let me put that in there so you can also take care of that when you do the square rooting. So come down, that's going to be, again, when I put everything together, like I said, some values will become others. So this is, another way to write joules is kilograms, and then it's also multiplied by meters per second squared. So it's meters squared. All this is in there. Instead of that's what joules mean. And so meters squared and divided by seconds squared. Okay, so all that's inside of there. And then when we put it all together in the end, the square root will take care of the meter squared and the second squared and remove that as well. But what does it look like in the final phase before we calculate? Take it one more time. That's why I said this is the most difficult part. I want to get this one out the way because it's a monster. So the kilograms and the meter squared and the second squared, they go away in this step. And you're going to be just dividing by this part here. And the kilograms will cancel out with the kilograms in the numerator where you had joules. So now you have this problem here. The parentheses, because all that's going to be square rooted. And this just becomes meters second, not squared. Or m over s if that works for you. All right, so we're at the calculation part. What's the velocity? Well, we take our trusty calculator, which is in Symbolab, right? Where are you at? I think you're right here. And I can get rid of all this. And what do we have? Well, let's take it slowly. Uh-oh, that's Isaiah's. Oh, you may. Okay, is he in here? You made it. Kind of late, but you made it, dude. You got a lot to catch up on. Um, Let me continue. You might want to start opening a Google Doc, Isaiah, and finding today's assignment. Where I'm gonna give you guys a couple minutes to finish typing everything up, and then I wanted to work on number three. And I'm gonna give you about like 5 to 10 minutes to finish it, and then we're gonna knock out three. You'll still have problem one that you got to finish though. Okay, so velocity, we calculate that by first doing what we have in the setup, and that's we're going to use a square root here, and then we type in what we need. So I need a fraction because this is division right here. So I'm going to hit this, and I have 72, and that's going to be divided by 2. It's going to be divided by my zero point 0.5 multiplied by my 0.22. And this is technically the way I was trying to put it into the document so you can see it. I don't know if you noticed that. So the recording will be available later on, but this is what I was trying to attempt with that symbol. Like, see how that bar comes across. So that is going to change the value once we crunch the numbers to 25.58. So 25.58. And again, this is in meters per second. Right now, that's the end of the problem for number 2. Okay. What was I trying to do with this? Blow that up so you can see everything. And then I want to make sure this is bolded because that's the final step. And that's pretty much all the steps. As I said before, this problem was a monster by itself anyway. Okay, so I'm going to take a couple of minutes. Mario, how far along are you? Did you get all these steps, or do I need to leave it here for a second?
Yeah, I still gotta copy some down.
All right, so let me know when I can scroll back up and let Isaiah's catch up to the initial steps of the problem. But get this down. I'm gonna give you guys about 5 minutes. When you're done, Mario, let me know so I can scroll up. Take this moment to stretch your legs, go to the bathroom, get something to drink, whatever the case may be, and then we're gonna continue after 5 minutes time on problem number 3.
You can scroll down.
You said I can scroll up. Is that what you said?
Yeah.
Okay. So this is the beginning of the problem. We get started with 2. Okay, you see that, Isaiah? So I need to blow up some more.
No, you're good, Tyler.
Okay. All right. So just tell me when to scroll down as you take care of what you got to. And again, the video will be available later on, guys. Okay, guys. How are you looking? Because we was about to jump into problem 3. Isaiah, did you get caught up or no? You there?
Just give me like 1 second. I'm gonna take a picture of this real quick, and then yeah, you can scroll down.
Okay.
All right, go ahead, Tyler.
Okay. So we're gonna move to problem 3, which is a lot more simpler than 2 was. And then 1, you end up solving for the math. So you do similar algebra. Hold on, let me see if- You probably can't. You probably can't hear me too well. Now you should be able to hear me. Y'all hear me better now or no? Okay, I guess you can.
Yeah, I can hear you.
Okay, because I didn't have the headphones on, so it probably sounded far away. The first thing we want to do is we want to use the same equation for kinetic energy that we used earlier. So let me scroll up to that. And it's this equation here. So I'm just going to take these and say, hey, we got to do that again. Come down, and that's what we're going to start with. So this one is real easy and fast. You simply got to plug everything in and get kinetic energy, because it says what is the kinetic energy as the final part. So let's take a minute to set up our known and unknown values. Okay, where is that at? I'm trying to find my mouse, gentlemen. My bad. So I'm going to do my known and unknown. I'm just going to take that from here because we're just going to use it one more time. And I'm going to say, hey, there we go. Now, what we got to do is look at what the problem gave us. So let's start slowly. It says a 13 gram, right? So we definitely know we got to use that. And that'll be what? Well, let's go slowly through this. So mass is going to be equal to 13 gram. It's a goldfish. And there's a problem with this because when we do this calculation, we have to use kilogram. So we got to convert this to kilo. Let's do that real quickly. That was the only caveat to this one. So uh, to turn this to kilogram, you usually start off by putting whatever it is you want to calculate over 1. So mass, we're going to say is equal to 13 grams, but we're going to put this over 1 because we want to convert that. Okay. And like I said, I'm put it over 1. Where did it go? Come back here. Over 1. And we're going to do a quick calculation. Let's remember in a kilogram, because our goal is to get grams gone and leave or cancel out grams like we did in previous problems and leave only kilograms. So how do we do that? Well, let's think about it. What does kilo mean? This is a blast from the past question. It's like a review question for the test. Anybody know? That's 10 to the what power? We forgot, huh? So that's 1,000, right?
Third to the third power.
Yeah, to the third power. I didn't know if you said it or not because I couldn't hear anything. But yeah, that's exactly right as is. So if that's the case, in the denominator, we got to put however many grams that are equivalent to, and we just said it, a kilogram. So that's 1,000 grams, right? Move this over some. And in the numerator, because that's going to cancel out our grams for us, in the numerator, we got to put the equivalent of it, and that's 1 kilogram. So 1,000 grams are equivalent to 1 kilogram. So now I can cross out grams. like that, across our grams, like that. Now we just calculate. So what is our new amount that we can use in form of kilograms? Well, we take our 13, clean that up. We take our, like I said, our 13, and 13 times 1 is just 13, but a kilogram is there. And then it's divided by just 1,000 because 1 times 1,000 is 1,000 in the denominator, but grams are canceled. So it's just 13 over 1,000. And this is going to be kilograms. So far, so good. What does that become? Well, hey, let's use our trusty calculator real quick, right? That's going to be 13 divided by 1,000. And that gives us this here. So they say 0, but it should be a decimal value. I think this thing is tripping because I could just take this and move it over 3 times. In fact, here's another way to look at that in case it's acting up. 13 divided by 1,000. Only thing, okay, yeah, that's what I thought. Move it over 3 places. So you start at 3. If you want to use, like, if you have 1,000 or 10, you look at the zeros, and that's how many places you got to move it. So it starts at right behind that 13. It goes 1, 2, 3. So that's 0.013. Mass is equal to 0.013, and that's kilograms. We got that out the way. The next step is, what else did the problem give us? Well, they gave us the velocity there. That's the speed that we talked about earlier. That's going to be equivalent to our what? Well, it's 7.4, if you look up here, meters per second. Okay. I think we're doing good. We got a lot of stuff we need. Last part is, what is the kinetic energy? That's going to be equal to some number in terms of, where's the question mark? Joules. Now we're at the part where we, the fun part where you just plug everything in and, finish it off. So copy. And like I said, I'm going to put this here. This can come over. And when we plug everything in, should be kinetic energy is equal to, which is what we're looking for, our, what did we say? That was 1 over 2, but 0.5, because that's the same as the 1 divided by 2. Multiplied by our mass, which we said now is going to be 0.013 kilograms, multiplied by our velocity, which we said was 7.4, and that's meters per second. And all of that's going to be squared. So when we get to kinetic energy, we're going to put the numbers together, but all the dimensions cancel. We got kilograms like last time, matching with a meters squared and a second squared. They combine to make joules. So I'm just going to take the 0.5 and this, plug that in, and that's going to be multiplied also by our 7.4, and that's going to be squared, so let's not forget that. And then we end up with joules as the final value or final measurement, but we got to calculate all this. I'm going to take all this and see if I can put it right into Symbolab or Google. And that's not what I wanted. I wanted Symbolab, and do that. So it came out okay, good. Now, what do you give us? So it did it right. It did it very right. Okay, so that's 0.3, and we could say that's just 2 5s. So we say 36, 0.36. So that means the kinetic energy will be equal to 0.36, and that's joules. Okay, so that's the end of that problem. I'm going to bold that. And those are all the steps necessary for it. So if I were you, I'd take a moment, because we only got maybe 7 more minutes of class, and get this all jotted down. Okay. I'm gonna leave this here and blow it back out somewhere like that so you can see more of it. So take a moment to finish typing that up. Remember at the very top of the problem, you should have started with, you put this in there. You got one more problem to do on your own. And I think Isaiah's is around. I could probably knock that problem out first. And then as people come in, go through this again in second period. But definitely get this part done. So when you get ready to do number one, all you gotta do is focusing on typing everything up. So take a few minutes. How's everybody doing? You got it? Got it copied so far, or not really?
Yeah, I got it. I'm good.
Okay, okay. That was Isaiah. So what about you, Mario?
I'm still copying down.
Okay, okay.